NASA's Mars Atmosphere and Volatile Evolution MAVEN spacecraft has long been a beacon of scientific exploration, sending back invaluable data that has reshaped our understanding of Mars and its transformation from a warmer, wetter world into the cold, arid planet we know today. Launched in 2013 and arriving in Mars orbit in 2014, MAVEN's mission was to investigate the upper atmosphere of Mars, focusing on how the planet lost much of its original air due to the harsh effects of solar radiation and space weather. This knowledge not only advanced planetary science, but also provided insights into the atmospheric processes of other planets, including Earth. Over the course of its decade-long mission, MAVEN far exceeded expectations. What was initially designed as a primary mission with a fixed lifespan evolved into a cornerstone of Mars atmospheric science. The spacecraft helped to confirm that solar wind and radiation had a significant role in stripping Mars of its early atmosphere, a crucial finding for understanding the planet's current uninhabitable conditions. MAVEN's prolonged operations made it one of the most enduringly successful missions in planetary science, providing a wealth of data that continues to inform current research on Martian history and future exploration. However, in December 2025, MAVEN experienced a sudden and unexpected failure. The spacecraft, which had been in regular contact with Earth, went silent after passing behind Mars in a routine orbital alignment. Such maneuvers are normal for spacecraft operating in Mars orbit, and they usually do not result in any technical issues. When MAVEN failed to re-establish communication, the situation quickly grew more concerning. Engineers at NASA initially reviewed the data collected from a recent radio science experiment conducted just before the loss of signal. This telemetry revealed that MAVEN had begun to tumble in orbit, disrupting its planned trajectory. The spacecraft was no longer maintaining the orientation necessary to ensure proper antenna alignment and power generation, which are critical for communication and data transmission. This deviation from its orbit made it increasingly difficult for engineers to regain contact with the spacecraft, and repeated attempts to do so have thus far been unsuccessful. Despite the failure, NASA officials have yet to formally declare MAVEN's mission ended, though they have acknowledged that the prospects of recovering the spacecraft are very slim. The situation is particularly striking because of the timing. MAVEN had recently played a pivotal role in observing 3I/Atlas, a rare interstellar object that passed through the inner solar system in late 2025. During the object's closest approach to Mars, MAVEN captured ultraviolet images of 3I/Atlas, detecting its hydrogen halo, a vast cloud of gas surrounding the object's nucleus. This unique observation provided scientists with crucial data, allowing them to distinguish emissions from the interstellar object from those of Mars' own hydrogen corona. This ultraviolet measurement became one of the most important pieces of data in understanding the characteristics of the interstellar object, which was observed by multiple platforms as part of one of the most comprehensive observation campaigns ever conducted on such a visitor. NASA's Mars Reconnaissance Orbiter and Perseverance rover also participated in the observation of 3I/Atlas. The Mars Reconnaissance Orbiter used its high-rise camera to capture high-resolution images of the object's coma from tens of millions of kilometers away. Meanwhile, Perseverance detected the object as a faint smudge in the Martian sky, capturing a completely different angle of this interstellar guest. These collective efforts painted a multifaceted picture of 3I/Atlas, offering detailed views of its composition and behavior. However, despite the spacecraft's vital role in the interstellar object's observation, NASA has emphasized that 3I/Atlas posed no danger to Mars or any of its spacecraft. The object passed at a safe distance and is now continuing on its trajectory through the solar system, with no indication that its passage had anything to do with the communication failure of MAVEN. Even with no direct link established between 3I/Atlas and MAVEN's loss of contact, the timing of the failure has drawn more attention to the vulnerabilities associated with long-duration space missions. MAVEN was designed to operate for a specific period, but like many space missions, it far outlasted its original expected lifespan. Over the years, The spacecraft endured constant exposure to radiation, thermal fluctuations, and mechanical wear and tear, all of which take a toll on spacecraft equipment, especially when they operate far beyond their design limits. These factors make space exploration inherently risky, and MAVEN's failure underscores the challenges involved in maintaining communication and control over spacecraft that are functioning well beyond their intended lifetimes. The loss of MAVEN highlights the growing challenges for planetary science, as the field continues to rely on long-lived, resilient spacecraft to investigate distant objects in the solar system and beyond. MAVEN's mission exceeded its original expectations, but it did so at the cost of enduring years of difficult conditions in space. The spacecraft's role in Mars atmospheric science was instrumental in providing insights that have reshaped the understanding of Mars evolution. But with MAVEN potentially lost, it also raises significant concerns about the future of similar missions that may be subject to the same risks. Many of NASA's most groundbreaking discoveries, particularly in the field of planetary science, depend on spacecraft that operate well beyond their original design lifetimes. MAVEN's extended operations were a testament to the durability of space hardware, but this success also masks the inherent limitations of the spacecraft's longevity and the ultimate fragility of these machines. As interstellar objects like 3I/Atlas are detected more frequently, there is an increasing need for resilient observation platforms capable of operating over long periods, with robust systems that can endure the harsh conditions of space for decades. MAVEN's loss is a poignant reminder that the space exploration community must continuously innovate to ensure the longevity of spacecraft. The challenge of maintaining spacecraft far beyond their design specifications requires not only technological ingenuity, but also careful consideration of risk management and redundancy strategies. This incident also highlights the importance of building spacecraft capable of withstanding the rigors of space travel for extended periods, with contingency plans in place to handle failures in key systems, such as attitude control and communications hardware. As the exploration of Mars and other distant celestial bodies continues, the need for reliable and long-lasting spacecraft will only grow. In particular, NASA and other space agencies must develop strategies to mitigate the risks of long-duration missions, including greater redundancy in spacecraft systems, more resilient communication technologies, and improved designs for attitude control and power generation. Only through such advances can the scientific community continue to unlock the mysteries of Mars and other planets in the solar system, pushing the boundaries of what is possible in space exploration. While the potential loss of MAVEN is a significant blow to the scientific community, it also serves as a call to action for future missions to learn from this experience and develop better systems to protect spacecraft from the inherent risks of space travel. The end of MAVEN's mission may mark the conclusion of an era in Mars atmospheric science, but it is also a stepping stone toward improving the resilience of future space exploration efforts. Despite the failure, MAVEN's contributions to our understanding of Mars remain invaluable, and the data it has sent back over the years will continue to inspire future generations of scientists and explorers. The lessons learned from MAVEN's mission will undoubtedly shape the design and execution of future interplanetary and interstellar missions, ensuring that the legacy of this groundbreaking spacecraft lives on in the next generation of planetary science.